Welcome physics students. In today's video we'll be looking at Newton's second law and focusing on some basic applications. Now most people are aware of the equation F equals ma, just remembering that F represents the net force on an object, and we'll be using some diagrams today to try and explain how we calculate quantities such as forces, masses and acceleration through Newton's second law. So let's look at some examples. Example number 1, calculate the acceleration A of the object. So we have here a 10 kilogram object. There's a force to the right of 100 newtons and there is a force to the left of 40 newtons. And the question is, calculate the acceleration. So first of all, we need to construct a force equation from this diagram. Please note, we're going to take the direction of the acceleration or net force as positive. On the diagram, we have acceleration moving to the right. So we're going to take that as the positive direction. The net force is to the right, it's the positive. This also means that the 100 Newton force to the right will be positive, and it's being opposed by the 40 Newton force to the left. So I'm going to take 40. That's going in the opposite direction, so it's allocated a negative sign. So that's equation 1. F net equals 100, take 40. Now we're going to use the equation of F equals ma and substitute that into equation 1. So where we have F net, we're now going to have ma. Ma is equal to 100, take 40. We now substitute our values of m is 10 kilograms, a is the unknown. We can simplify that. 100 take 40 equals 60. And finally, if we divide 60 by 10, we're left with a equals 6 meters per second squared to the right. Example number 2, we now want to calculate the force acting on the object. So in this situation, we've got a 20 kilogram mass. There's a force to the right. Its value is unknown. We have a force to the left of 100 newtons. And we know the acceleration of this object is 5 meters per second to the right. Once again, we'll construct a force equation from this diagram. And as always, we're going to take the direction of the acceleration or the net force as positive. So the acceleration is to the right, so all arrows to the right will be positive. So the net force will be to the right. It follows the same direction as the acceleration. F, the unknown force to the right, and it's opposed by 100 newtons to the left. So we take 100 to the left. So that's our equation 1. We now substitute in, instead of F net, we substitute in the equation from Newton's second law, F net equals ma. So I now have ma equals F, take 100. Substitute our values, the mass is 20 and the acceleration is 5. So that simplifies to 100 equals F, take 100. Accordingly, F, the unknown force to the right, will be 200 newtons. Example number 3 has a 15 kilogram mass. The acceleration is 4 meters per second to the right. There's a force pulling to the right of 100 newtons, and there's an opposing force F to the left. And we're trying to calculate what is that unknown force. We construct our force equation looking in the horizontal plane. Again, the acceleration is to the right, which means the net force will also be operating to the right. So this 100 newtons to the right will also be positive, and the opposing force to the left will be negative. So we have a statement, F net equals 100, take away F, the unknown force. That's equation 1. Let's now substitute Newton's second law. F net is equal ma into equation 1. So we now have the equation ma equals 100, take F. We substitute in the mass of 15, the acceleration of 4, and we're left with 60 equals 100, take F, and accordingly, F, the unknown force, is 40 newtons, and it's operating as the diagram shows to the left. Example number 4. In this case, we want to calculate the mass of the object. We have an unknown mass, a force of 80 newtons to the right, a force of 20 newtons to the left, and an acceleration to the right of 12 meters per second. Let's construct the force equation in the horizontal plane for this diagram. Again, the acceleration is moving to the right, so that will be the direction of the net force also, and we're going to consider that as a positive direction. So the net force to the right is generated by the 80 newtons to the right, as shown on the diagram, and opposed by the 20 newtons to the left. That's equation 1. Let's substitute in. F net is equal to ma, and we now have ma equals 80, take 60. Substitute our values. M is the unknown, so we leave that variable as the letter m. A is 12 meters per second, and we now are left on the right hand side with 80 take 20, which simplifies to 60. So to find m, we divide 60 by 12, which calculates an unknown mass of 5 kilograms. Example number 5. Let's calculate the acceleration A of the object. So we have a 40 kilogram mass with a force to the right of 50 newtons and a force to the left of 50 newtons, and the acceleration is the unknown. Let's first of all construct a force equation from this diagram. So in this case, we actually don't know the direction of the acceleration or the net force. So our statement is simply F net is equal to 50 to the right and opposed by 50 to the left. They effectively cancel each other out. So net force is 0. That's equation 1. Let's substitute in F net equals ma. Ma equals 0. mass of 40, A is unknown, and the net force is 0. This results in an acceleration of 0 meters per second per second. Looking at this diagram, we can see clearly that if the force to the left is 50 newtons and the force to the right is 50 newtons, they will cancel each other out with a net force of 0, therefore the acceleration has to be 0. Finally, our last horizontal example, example number 6, let's calculate the force on this particular object. In this case, we've got two forces to the left, one of 70 newtons and one of 50 newtons, one force to the right, an unknown value of F, and the object is accelerating at 2.5 meters per second to the left. Let's construct our force equation from this diagram. So we're looking horizontally. And of course, if the acceleration is going to the left, that means our net force is to the left. So we're going to take that as a positive direction. So the net force is to the left, and that's being generated by the 70 and 50 Newton forces individually to the left and being opposed by the unknown force F to the right, hence the negative. This is equation 1. As we've been doing, let's substitute in F net equals ma into equation 1. So F net is replaced by the terms ma, and still on the right hand side is equal to 70 plus 50 and opposed by F. Let's substitute in a mass of 40, an acceleration of 2.5, and we still have on the right hand side 70 plus 50, take away F. That can be simplified to 100 equals 120 take F. So accordingly, F is 20 newtons to the right. Let's now look at a couple of vertical examples. Exactly the same process, only we're looking vertically. Calculate the acceleration of the object. Step 1, again, let's construct a force equation from the diagram. We know the acceleration is upwards, so again, that means our net force will be upwards. We will take that as the positive direction. So the net force will be upwards, and it will be generated by the 198 newtons pulling up and opposed by the force due to gravity pulling down. That's equation 1. Once again, let's substitute in F net equals ma. So F net becomes ma is equal to 198 and opposed by Fg. ma equals 198, and force due to gravity can be written down as mg. That's the equation to work out the force due to gravity. Substitute our values in. M equals 10. A is the unknown value. 198 take away the mass of 10 times the gravity of 9.8. VCEE requirement states that the gravitational field strength of 9.8 newtons per kilogram should be used for our calculations. Let's simplify this further. 10 times A is equal to 198 take 98. So 10A equals 100. A therefore will be 10 meters per second in an upwards direction following the net force. Example number 8. Calculate the unknown force F on the object. Once again, let's step 1, construct a force equation from the diagram. So the net force follows the same direction as the acceleration. It's upwards. So that means F unknown is generating the upwards force and being opposed by the force due to gravity, hence the negative. That's equation 1. Let's substitute in F net equals ma on the left hand side of equation 1. That leaves us with ma equals F take the force due to gravity. Let's further simplify that, where Fg, the force due to gravity, can be written out as mg. And now we substitute in our values. The mass was 50, the acceleration was 5. The mass was 50, and the gravitational field strength was 9.8 newtons per kilogram. That can be further simplified, so 50 by 5 is 250, and 50 times 9.8 is 490. So to find F, we simply add the 490 to the left-hand side, and we have F equals 250 plus 490, which equals 740 newtons upwards. Example number 9, calculate the mass of the object. So step 1, construct a force equation from the diagram. So we can see from our diagram the acceleration is in an upwards direction, therefore the net force will be upwards. That means the force of 984 newtons is generating an upwards force, and the force due to gravity is opposing that in a downwards direction. So F net equals upwards, the 984 newtons is upwards, and the force due to gravity is downwards, so we're taking that away. It opposes the 984 newton upward force. So that is equation 1. Let's substitute Newton's second law. F net is equal to ma. So our F net becomes ma is equal to 984 take Fg, the force due to gravity. Let's expand that. Our Fg becomes mass times gravity. And we can substitute in our values. M is an unknown mass. The acceleration is 2.5. The product of that is equal to 984 take away m times 9.8, which is the gravitational field strength on Earth. 2.5 times m equals 984 take away 9.8 times m. If we could group the m terms across the left-hand side, we'd be left with 12.3 lots of m is equal to 984. And accordingly, the mass would come out to 80 kilograms. Example number 10. Calculate the force F on the object. So in this scenario, we have an acceleration of the system downwards, which means our net force is downwards. So step 1, construct a force equation from the diagram. All right, so our net force, as we said, is downwards because the acceleration is downwards. That means that our force due to gravity must be generating that downwards force. It's also downwards, and it's being opposed by some force that's generating an upwards force, F, the unknown force. As the net force is going downwards, this is written as a negative value. That's equation 1. Let's now again replace F net with the equation MA. So we have MA equals Fg, the force due to gravity, take away F, the force going upwards. MA equals mg take F, because the force due to gravity can be expanded into mg. Substituting our values, we've got a mass of 25 kilograms, an acceleration of 4 on the net force. We have a mass of 25 and a gravitational field strength of 9.8 newtons per kilogram, and an unknown value for F. We simplify that, we end up with 100 equals 245 take away F, which means F is equal to 145 newtons in an upwards direction. Our final example, example 11. Calculate the force F on the object shown. So here we have a system, acceleration is upwards, which means our net force is upwards, which means all these forces going upwards are going to be expressed as a positive value, whereas the force due to gravity going downwards will be opposing the net force direction. It will be allocated a negative value. So first of all, let's construct our force equation from the diagram. So net force is upwards, as we stated, which means 588 plus the unknown force of F are going upwards, and the sum of these two forces is being opposed by the force due to gravity, Fg, which is operating downwards, hence the negative value. That's equation 1. As always, let's now substitute Ma for F net. Ma equals 588 plus F, the upwards force, and opposed by or taking away the force due to gravity. Let's expand that in, Fg equals m times g. So our numbers substituting in give us a mass of 60 of our object being accelerated by an acceleration of 5 meters per second, and that product will be equal to 588 plus F, take away the force due to gravity, which will be mass of 60 multiplied by gravitational field strength of 9.8 newtons per kilogram. 300 equals 588 plus F, take 588, the plus 588 and the minus 588 simply cancel out to leave us with F, the unknown force, is 300 newtons in an upwards direction. Thank you for watching this video. I hope it's given plenty of examples of how we can analyze simple systems using Newton's second law, F equals ma. It's important to understand how we can state an equation analyzing either horizontal or vertical force diagrams, and from that use F net equals ma to find an unknown quantity, whether that be mass, acceleration, or an unknown force. If you've learned something from this video and believe others could, please like, share, comment, and subscribe. And as always, thanks for watching.